Hey everybody, welcome back. So recently I have been attempting to find a way to quantify the strength of printed parts for filament comparisons. And I've watched what some of the other people on YouTube do, and I like what some of them do, and what others do doesn't really quantify it very well unless you think jumping up and down or hanging or hitting something does. But I would really like to find a more scientific method, or at least it's not quasi-scientific. So my first thought, and it's probably because I watched too many Project Farm videos, was to print a hook, take a hanging scale like this cheapo fish scale, put the hook in it, pull on it till something gives way, and record the weight on it. But the problem with that is this inexpensive analog fish scale. It goes up to 50 pounds, which is more than enough. But it doesn't have a peak hold. I can't record what the maximum weight was before it broke. And I looked at other crane scales, and you've got to go pretty pricey in a crane scale before you can get a peak hold on it, because that's really not what crane scales were designed to do. So my next thought was to get rid of the hooks and use one of these. Now this is a torque adapter. This adapter, you put your breaker bar or your ratchet in one end and your socket on the other. You turn it on and you can set a torque you want to go to, and then it will beep and flash when you reach that torque. It also has a peak hold on it, meaning if the bolt breaks, you can pick the thing up off the ground, and assuming you didn't break it, you can read the maximum torque it reached before it broke. So I thought, perfect. So the hooks are out. I needed something I could break, and break reliably. And I also thought of maybe doing some type of deflection test with something like this. And yeah, I have one of the digital ones around someplace, I just can't find it. So these were my first attempts, this. And the problem with these is they're way too strong. I was rounding the hole out on all of them before I was breaking the center out. And what I wanted the center to break out. So then I decided to go with a spoke design, and that's these here. But the problem with these, though, again, it's too strong. You can see the amount of deflection I got, but I was still rounding that center hole out. And that's not what I want. I want to break the center out and get a peak torque reading on it. So my next attempt was I made the spokes much, much thinner. But the problem with that is it broke before I really got much of a reading on the torque adapter. So I went back to my original thickness of spokes. I just cut the number of them down, and I also cut the thickness of this down, both in an attempt to make it weaker, plus to make it print faster, because I am destroying these. So I really don't want to do a 2-hour print for something I'm going to destroy. I'd like to keep it down to 1 hour. So I think these work pretty well. I did break some of them on camera for you guys to see, and I would appreciate your opinions of my methodology. If you can think of something better, let me know. And yeah, maybe I'll have a real method going forward when I want to test the strength of different filaments or different printed parts. So let's go out to my garage and let's break some stuff. Okay, I hope I have a decent angle on the dangle here. And just to give you guys an idea how this works, I have it set so that when it powers up, it comes up into that peak hold. And I'm just going to put a crescent wrench on this end. And now when we put some torque on it and let go, it stays at the highest reading. So that's what we're going to do. So I'm going to take the first of my pieces, and the blue is PLA, and that natural whitish colored one is ABS. So let's see how this works. I have not tried this particular set of them yet. So I am gonna stick it in the vise, hopefully not tight enough to crush it, just tight enough to hold it. I'm gonna stick my adapter in, power it up. It should come up and say P-top, and it does, and here we go. Oh, that was perfect. Perfect. All right, look at that, huh? That snapped that center right out of there. So that's what I was looking for, and it did it at 8.7 foot-pounds, which is a little lower than what I was hoping for. But let's go ahead and let's try the one in ABS. So I'm going to power the adapter down. Everything I do, I expect to be better than PLA. So if PLA is at the bottom end of this, I'm okay with that. So turn this back around. Should come up to P-top. And here we go with ABS. And ABS broke at less, look at that, it broke at less than the PLA did, at 5.5 pounds. I find that pretty interesting because I've always considered ABS to be considerably tougher. Maybe I just have a crappy ABS here. I don't know, but there you have it. ABS actually broke at a less torque reading than did PLA. I don't know what to make of that. Why don't you guys tell me what you think of it down in the comment sections below. What do you think of my testing methods? You know, if you got a better idea, let me know. Hope you guys enjoyed this video. Hope we're both learning something, because I think I just did. Because this is the first one that really broke out reliably for me at a torque reading that I think is probably accurate and didn't round that center hole out. Anyway, hope you guys are having a great weekend, and I'll catch you the next time. Bye for now.